All right, so we're going to continue on with Unit 3, which is going to focus on fluids, learning target 9. Took out a lot of slides for this video that in class we would actually do, but for the purposes of kind of streamlining this video, I'm going to skip those in this presentation. All right, so the first key vocab term you need to know is pressure, and this is the amount of force exerted per unit area of surface. Fluids exert pressure evenly in all directions, and there's the pressure equation. Now, I'll go ahead and say that by yourself, you're not going to be asked to do any of these calculations. We might do some in class as a whole class, but you won't be given a big assignment to do these calculations. So buoyant force is the upward force that keeps an object immersed in or floating in a liquid. All fluids exert an upward force or the buoyant force on matter. Pressure increases with depth. More force is pushing up on an object than pushing down results in the net force pushing up. Archimedes' principle. The buoyant force of an object in a fluid is an upward force equal to the weight of the fluid that the object displaces. Archimedes' principle is all about weight versus buoyant force. Okay, so Archimedes' principle basically deals with why things float. Okay. So flotation, an object will float or sink based on its density. So you need to remember what density is and how can we use density to determine flotation. So an object that is more dense than the water that it will displace will sink. An object that is less dense than the water that it will displace will float. Pascal's principle. So a change in pressure at any point in an enclosed fluid will be transmitted equally at all parts of the fluid. So if you increase the pressure at any point in a container of fluid, the pressure increases by that amount at every point in the container because remember, fluids exert the equal amount of pressure in all directions. So here you can calculate Pascal's principle. So P1 equals P2. The force of 1 divided by the area of 1 equals the force of 2 divided by the area of 2. Okay, you will not have to do this, but you do need to be able to P1 equals P2. Pressure 1 equals pressure 2. So fluids move faster through small areas and large areas if the overall flow rate stays the same. And this deals with pressure. Smaller area for the fluids to get out will cause them to move faster. This is what happens when you put your thumb on the end of a water hose, shrinking the opening of the hose, making the water come out faster. So viscosity is the resistance of a gas or liquid to flow. So viscosity depends on particle attraction. More attraction between the particles means it's going to be more viscous or flow slower. Less attraction between the particles means it's going to be less viscous or flow faster. So Bernoulli's principle, as the speed of a moving fluid increases, the pressure of the moving fluid decreases. Okay, so as it moves faster, the pressure will decrease because it's escaping, right? So that's where we'll stop today. Be sure you complete the video form. And again, there's a lot of slides that we'll do in class that we're not doing on this video that will hammer some things home, but we'll also do assignments that will help these principles. Thank you.